This is our last lesson for chapter 11, and it is on simple radical equations. Okay, so we're going to solve equations that have radicals in them. So an equation that has a variable in the radicand is called a radical equation. So I can have an equation that has a radical in it, but as long as the number underneath the radical sign, okay, or the radicand, is just a number, then it's not considered a radical equation. It's only a radical equation when there's a variable in the radicand. Okay, so if we look at our examples here, there's a d, so I'm taking the square root of d. Here I have an x. Okay, so these are radical equations. So there's a difference between a radical equation and an equation that just has a radical in it. Okay, and the difference being that the variable is within the radicand. So simple radical equations are solved by isolating the radical on one side of the equal sign and then squaring both sides of the equation. So when we were solving absolute value equations, we had to have the absolute value by itself on one side before we could write our two equations. This is similar in that we have to have the radical by itself on one side, and then what we're going to do is we're just going to square both sides. So if we look at our first example, we have 140 equal to the square root of 2 times 9.8 times d. Okay, so this whole thing is the radicand. There's my variable, so this makes it a radical equation. And my radicand, or my radical, is already on one side by itself. Okay, so what I'm going to do is I'm just going to go ahead and I'm going to square both sides. So here's what we're going to do. So I have 140, and I'm going to square that. I have this 2 times 9.8 d, and we're going to square that. So I get 1,000, actually 19,600, and that's going to be equal to, and this is just, when I take the square root of this, when I square it, basically all I'm doing is taking what's underneath the radical. So 2 times 9.8 is just 19.6, so this was 19.6d. Okay, and the reason I had it written like that is because sometimes you'll see formulas where things look kind of like that. Okay, so we just multiply it and we squared both sides. So now I'm just going to solve for d. So I divide both sides by 19.6, and ooh, look at that, it worked so well. So d is equal to 1,000. Okay, so in this case, d has to be positive, okay, because there's only one of them, and if it's negative, then I can't take the square root of a negative number. So in this case, d must be positive. Okay, in some equations, some radical equations, you might be looking for a positive and a negative, but only if the variable has an exponent, okay, a positive exponent. So in this case, we're just looking for the positive, so d is equal to 1,000. If we look at our next equation, notice that the radical is not by itself. It has this plus 2, so I got to get rid of the plus 2 before I can square anything. So I have the square root of 5x plus 1 is equal to 4. The radical is by itself, so I'm going to go ahead and square both sides. And I get 5x plus 1, because when I take a radical and I square it, it's just whatever I had underneath the radical sign. So 5x plus 1 equals 16. Now I'm going to go ahead and just solve for x like I normally would. So 5x is equal to 15, x is equal to 3. And again, we're looking for just the positive, because if x was negative, then this, we can't take the square root of this. Okay, so x is equal to 3. Let's look at example 3. Here we've got two terms, so an expression that's underneath the radical, and then we've got this 2x out here, okay? So we got a variable underneath the radical, and we've got a variable that's not underneath the radical, okay? What we have to do is we still have to get the radical by itself. So let's do this. Square root of 11x squared minus 63 is equal to 2x, okay? Now we're going to square both sides. Okay, and make sure you square the whole thing. This is just going to be 11x squared minus 63. This becomes 4x squared. Okay, now I'm going to just solve for x. So I'm going to combine my like terms. So I'm going to subtract 4x squared on both sides. I'm going to add 63 to both sides. So I'm going to end up with 7x squared is equal to 63. So x squared is equal to 9. And x is equal to 3. Okay. Could x also be negative 3? Sure, let's find out. So let's check. So if x is positive 3, we'll put a plus or minus here, and then we'll put a question mark. If x is positive 3, I would have 9. 9 times 11 would be 99. 99 minus 63 would be 36. Square root of 36 would be 6. So if 6 would be equal, so we'd have 6 minus 6 would give us 0. So positive 3 works. Let's try negative 3. If I had negative 3, this would still be 9. 99 minus 63 is 36. Square root of 36 is 6. But this would then become 6 plus 6, which is not 0. So in this case, only the positive works. You need to check them both. Okay, so don't just say, oh, well, it's plus or minus 3. You need to make sure that you check them both. Okay, let's look at our proof now. All right. So everything that we've learned so far, as far as solving radicals and quadratic formulas or equations, you need to take all of that into account. Okay. So here I have the square root of 3x over 2 equal to 120. My radical is by itself, so I'm going to go ahead and I'm just going to square both sides, and I'm just going to write it just like that. So this just becomes 3x over 2, because when I have a square root and I square it, it's just whatever was underneath. 120 squared is 14,400. Okay, and I'm just going to solve for x. So 3x is equal to 28,800, and x is equal to 9,600. Okay, it has to be positive because the x does not have a exponent. If I look at my next one, I need to get rid of this negative 3 so that I have the radical by itself. So I'm going to have 6y minus 2. The square root of that is equal to, if I add 3 to both sides, I get 10. I'm going to go ahead and square both sides. So I have 6y minus 2 is equal to 100. I'm then going to go ahead and just solve for y. So I have 6y is equal to 102. And y ends up being equal to 17. Okay, again, it has to be positive because there's no exponent here, so this would have to be positive. My last example, I have square root of 5x squared plus 16 minus 3x equals 0. I'm going to make sure I have my radical by itself on one side first, and then I'm going to square both sides. Make sure you're squaring this whole thing here. So I get 5x squared plus 16 is equal to 9x squared. I'm then going to solve for x, so that's going to give me, if I subtract 5x squared on both sides, I have 16 is equal to 4x squared. Divide both sides by 4. And I have 4 is equal to x squared, so x is equal to 2, and it could be plus or minus 2, but because of this right here, I know that only one of them is going to work, and it's probably going to be the positive. So 2 squared is 4. 4 times 5 is 20. 20 plus 16 is 36. Square root of 36 is 6. 6 minus 6 would give me 0, so it's only going to be positive 2 that works for that one.